Does the discovery of similar mathematical ideas across the world at different times tell us something about the nature of reality?
Yeah, well, I think a lot of the examples that you see of that kind of thing tend to be more historical. And I absolutely wish no insult to mathematicians of history, but maths was easier back then because a lot of the ideas that we were finding were very basic things about number and about structure and about prime numbers and, the patterns and it's sort of simple geometrical constructions and things like that. And obviously at the time, as a species, we didn't have the advanced mathematical knowledge that we do now. So a lot of it was just sort of laying the groundwork for that and finding those sort of fairly simple ideas. And I'm not going to say low-hanging fruit, but the idea that mathematicians in ancient Greece, the problems that they were working on are things that we now teach in school because they are those sort of very basic foundations of mathematics. But at the time, that was completely new and no one had actually written that down before. And I think a lot of those discoveries are of those sort of very fundamental key concepts in mathematics that, Pascal's triangle is a beautiful object. It's got so many wonderful patterns in it. It's got so many connections to other areas of maths, and it is really simply defined. But actually, just anyone could write down those numbers, but actually seeing those patterns and seeing the importance of it was a really, really crucial step at that point in the history of maths. And the fact that it happened in several places, I'm not massively surprised by, because it is something that is quite sort of fundamental and important. And I think I'm not saying that nowadays there aren't mathematicians on other sides of the world who happen to pick up the same problem at the same time and come to the same answer, but I think you'll see a lot more examples of that kind of thing looking back into history for that reason. And then a lot of the way that maths works is it sort of builds on previous things, so that the level that we are as a species will kind of increase over time. Also, because of the nature of the world and the way that things worked out, a lot more of the maths that you hear about is from the sort of 18th century Europe, which was when a lot of the maths was kind of written down, I guess, rather than or written down in a way that was then shared and kind of propagated around the world. But I think there'll be a lot of people who made discoveries in mathematics that we never find out about. They wrote it down somewhere and it got lost, or they did this work and they told someone, but that didn't necessarily mean that it became part of mathematical sort of knowledge generally. Possibly a time before the world realized that we were going to become one connected global international thing where we all just share information and knowledge and improve our knowledge as a species. So it's a complicated question because a lot of that stuff is quite political as well, and it's sort of a philosophy of maths question. As I say, a lot of the early maths was done from a sort of quite practical standpoint. So a lot of the things about calculating pi, the area of a circle, was the thing that it was important to know if you were going to store your grain in a circular building or whatever. How much grain will I have? And those calculations were done for very practical sort of how much tax do you have to pay and how much, how many animals do you have in your herd and that kind of thing. In the early days, it was very simple but very functional in that sense. And it was only people like philosophers who had the time to sit around pondering about the nature of these things that could go beyond those questions of very immediate practical solutions to real problems. And, things like astronomy, looking at the sky, predicting the motion of the planet and that kind of thing, that was all sort of very practical stuff. And that's why a lot of the early maths tends to be focused on those types of things. But sort of philosophically, I guess, because there's sort of schools of thought around whether maths is something that we create or something that we discover. Like, does maths sort of exist out there in the universe separate from us and we're just, picking it off a tree like fruit, or is it something that we ourselves are actually creating? I think it's a difficult one, and I've probably been asked about this in interviews before, and I can't remember which way I've said, because I think I'm probably somewhere on the fence in between the two, because yes, these concepts, things like numbers and prime numbers and these geometrical structures and things, all do sort of exist without our interference. You can derive them separately. Different people can come to the same conclusion in different places just because they are very sort of fundamental. But then I think there are layers to it that actually the way that we choose to interpret it, the way that we choose to write it down, the notation we use, the aspects of each thing that we find important will influence the way that study is then kind of continued in the way that we develop that knowledge. So it's sort of a mixture of the two, because it is in itself a really beautiful idea that maths is sort of a collaboration between us and the universe. I guess that if you started off a fresh planet with the same humans on it, would we evolve maths in a slightly different way? Would we have different names for things, different notation? And I think there would be some concepts that were common, and I think they would be these kind of really fundamental things that people kind of develop independently all over the world. But we've now reached a stage where if someone looks at a particular mathematical structure, they can find out what that's called. Someone's already studied it, someone's already done some research on it, and they'll be influenced by that previous work, which again is in itself a wonderful thing, that maths is sort of building on the work of previous mathematicians. And this is something I'm really passionate about, the idea that we're kind of building a toolbox to share and use, but that in itself means that we're kind of going in a direction that we've already chosen.